So good evening, one and all present here. So let's start discussing the concepts of bond arithmetic. And in the bond arithmetic, we have discussed till now the pricing of bond. We have discussed about calculation of yield till maturity of the bond. Today we'll talk about the discussion of duration. So in duration, today we'll talk about two kinds of durations on a bond that is called macular duration. We'll talk about macular duration and we'll talk about modified duration. So while discussing on bond, we'll talk about the two forms of durations that is called macular duration and modified duration on the bonds. So basically, when we talk about duration, a duration you can understand duration as the relationship of payback, what we have studied in the case of corporate finance. So when we were studying the corporate finance, if you remember, that time when we hear the term called payback, payback means when you'll get back your money from the investment. So in if you start doing an investment proposal, so when you'll get back your money from the investment, and that we called as a payback. Similarly, when we study the bond market, the duration basically means the weightage time period when you will get back the value of the price what you have paid for the bond, that is basically called as duration. So if you remember, you can correlate duration with a term called payback of the investment management, and similarly you can correlate the term called YTM with the IRR for the investment management. So IRR also, if you remember, yield till IRR, internal rate of return. Internal rate of return can be correspond with YTM, because IRR we also talk about the minimum return what you get on the investment. Like the same way YTM also talks about the minimum return what you get when you do investment in the bond market till its maturity. And so the minimum return what you get, where all the interest what you receive during the continuous period of time, that will be reinvested at that minimum rate of return, that was called as YTM. So YTM can be understand as IRR whenever we study the bond market. Similarly, duration can be understand as the payback whenever we study the bond market. So if you try to plot the graph, if you try to plot the graph between the the price of the price of the debt instrument, if you try to plot the graph between the price of the debt instrument will with the YTM, yield till maturity. So if you see the graph, so the price with the YTM, if you see the graph, so you know that with the formula of price coupon, when you see this formula of price, this is coupon divided by 1 plus YTM to the power T, where T equal to 1 till N, plus face value divided by 1 plus YTM to the power N. So here if you see this, coupon and face value are constant. So with this you can say that the price is inversely proportional to YTM. With this you can say that the price is inversely proportional to YTM. So if you see the relationship between the price and YTM, it should be inverse relationship. The relation between price and YTM, if you see the relationship, should be inverse relationship, that when you increase the YTM, the price will decrease. When you decrease the YTM, the price will increase. The relation between the price and the yield till that should be inverse relationship. So this is the graph for that inverse relationship. So now, if you want to measure the graph, now if you want to measure the slope of this graph, so the slope of this graph is basically called as YTM. Sorry, the slope of this graph is basically called as duration. So when you see this graph, you can see the straight line curve. What between the price of the debt instrument with respect to the YTM. So if you try to measure the slope of this graph, if you try to measure the slope of this graph, what you're getting. So that slope of that graph is basically measured by the term called duration. So when we see the price of the bond formula, when we see the price of the bond formula, that is nothing but that is coupon divide by 1 plus YTM to the power T till it goes from t. The t is from 1, so the t is from 1, the t is from 1 to n plus the face value divided by 1 plus ydm to the power n. So this is the formula what we see for the price of the debt instrument. This is the formula what we see. And so here in this formula, let I write price by P and coupon by C and YTM as R. So I can write this like this: coupon divided by 1 plus R percent to the power 1 plus coupon divided by 1 plus R percent to the power 2 plus coupon divided by 1 plus R percent to the power 3, like this coupon divided by, so this is a price formula: 1 plus R percent to the power n plus face value divided by 1 plus R percent to the power n plus 1 plus R percent to the power n. So here I can, if I divide this, the price with respect to the R, if I divide the price with respect to the R, before that, I can write the same thing as coupon 1 plus R percent to the power minus 1 plus coupon into 1 plus R percent to the power minus 2 plus coupon into 1 plus R percent to the power minus 3. Similarly, coupon into 1 plus R percent to the power minus n. Okay, so plus face value into 1 plus R percent to the power minus n. So you can write it like this. So you can write like this. Now once you write it like this, now what you can do, if you do the differentiation, here all are in percentages. Okay, so here all are in percentages. Don't get confused with the percentage. So if you do the differentiation, of dp by dr, so you will get minus c1 minus 1 plus r per to the power minus 2 2c into 1 plus r percent to the power minus 3 minus 3c into 1 plus r percent to the power minus 4. Okay, so similarly you can say that you'll get minus of c minus of nc 1 plus r percent to the power minus n plus 1. Similarly, minus of n of f into 1 plus r percent to the power n plus 1. So minus of n plus 1. So once you get this relation, I hope you remember basic math differentiation. Differentiation, when we talk about differentiation, d by dx of x to the is equal to nx to the power n minus 1. You know the differentiation, d of dx of x to the power n. Similarly, you know the differentiation of d by d of AB, d by dx of AB, that is a dx, that is a dx, sorry, a differentiation of this is a db, that is a db by dx plus b into dA by dx. Basics of differentiation, what you studied in the schooling. So if you do the differentiation of this, you'll get this as a value. Now, if you can write this, you can write this as dp by dr. So I can write this minus of c 1 plus r percent to the power 2 minus of 2c 1 plus r percent to the power 3. Similarly, minus of nc minus of nc 1 plus r percent to the power n plus 1. Similarly, minus of nfb divided by 1 plus r percent to the power n plus 1. I can write it like this. So now I can write dp by dr is equal to, if I take minus 1, 1 plus r percent common, so I'll get c by 1 plus r percent 2c by 1 plus r percent square plus 3c by 1 plus r percent to the power 3. Similarly, n of c of 1 plus r percent to the power n plus n of fb divided by 1 plus r percent to the power n. So you'll get this as a relation. Once you get this as a relation, if you divide 1 by p with both numerator and denominator, to divide 1 by p with both numerator and denominator, so then you get the relation as c divided by 1 plus r percent plus 2c by 1 plus r percent square plus 3c by 1 plus r percent to the power 3. Similarly, I can write this as n of c of 1 plus r percent to the power n plus n of fb of 1 plus r percent to the power n divided by p. Okay. So this relationship, this what you can see, this relationship, what you see, this what you can see. So this is what we called as macular duration. This is what we called as macular duration. This we called as macular duration. This we called as macular. This we called as macular duration. This we called as macular duration. So the macular duration is nothing but, so this is macular duration c divided by 1 plus percent to the power 1 plus 2c divided by 1 plus r percent to the power 2 plus 3c divided by 1 plus percent to the power 3 till nc divided by 1 plus r percent to the power n plus n of divided by 1 plus r percent to the power n divided by p. This is called as macular duration. This we called as macular duration. So remember that term. This is what we called as macular duration. So macular duration, the term what we call this we called as macular duration. So altogether, this term what you get, we call this macular duration. Now, if you remember this formula, this if I put everything in this formula, so I can write 1 by p dp by dr, that is equal to minus of 1 by 1 plus r percentage, that is into macular duration. This is called as macular duration. And macular duration divided by 1 plus r percent is called as modified duration. So 1 by p dp by dr is equal to minus of modified duration. Remember the difference between macular duration and modified duration. So what is modified duration? So modified duration is basically, when I say modified duration, modified duration is basically, it is basically macular duration. It is basically macular duration divided by 1 plus r percent. This is called as modified duration. So remember the relation. So step by step, how to derive this formula, everything I have done here. So step by step, I have done derive this formula. So if that derivation is not important for you, this derivation is not important for you. If you are weak with mathematics, no need to try this derivation. Just see it once, just understand everything is interconnected. The purpose of showing you this is that they are interconnected. So if you understand basics of differentiation, then well and good. If you have no idea about calculus, and integration and differentiation, if you're weak with them, then no need to follow the steps. You can simply remember the formula What you have to remember, you have to simply remember the formula. You have to simply remember the formula. You just need to remember this. You just need to remember this. If you're weak in math, no need to remember the steps. Just remember this. This is called macular duration. This is what we called as macular duration. And then this is what we called as modified duration. If you're weak with math, you simply follow the formula. This is called as modified duration. Modified duration is macular duration divided by 1 plus r%. That is we called as modified duration. So modified duration you can't get it directly. So modified duration you'll get by step by step. First, you have to find the macular duration. Macular duration divided by 1 plus r% will give you modified duration. Okay, so once so you have to find macular duration, you have to find modified duration. So basically, durations when we talk about duration basically give us an impression about when we'll get back the money from our investment in the bond market. That is what duration basically talks about. So as you can see from this formula, that 1 by P dP by dr is minus or modified duration. What this minus sign basically means, the minus sign here basically means that the price and the YTM, the price and the rate of interest rate, they are inversely proportional to each other. So whenever the price will increase, the interest rate in the market will decrease. The other way, I should say the other way, that the price of the debt instrument depends upon the interest rate in the market. So whenever the interest rate in the market will increase, then automatically the price of the debt instrument will decrease. And whenever the interest rate in the market will decrease, then automatically the price of the debt instrument will increase. So everything is the factor of demand and supply. So in the case of demand and supply, whenever you do investment on your debt market instruments, you get an interest rate. The interest rate, what you get, either the interest rate are fixed interest rate, or either the interest rate is floating interest rate. So floating interest rate basically basically moves with what is happening with the market. So automatically the floating interest rate will keep on changing, but the fixed interest rate will remain the same. Suppose you have done investment in some debt instrument which is offering you 7% interest rate, and but if you see the interest rate in the market, FD and all give 4-5% interest, and you have done some investment in bond market which is giving you 8% interest, automatically that means that that the bond instrument is giving you very good return, better than what the market is actually giving on FDs and saving bank account and other PPF, other investment source. Automatically everyone will try to buy that debt instrument. When everyone will try to buy the debt instrument, automatically the demand for the debt instrument will increase. And because when the demand for the debt instrument will increase, automatically the price for the debt instrument will increase. So that is a relation what we understand, that the price and the interest rate, that the price and interest rate both are connected inversely. So whenever we see the interest rate altogether will affect the price of the debt instrument, and that change what we see on the debt instrument, we believe that change is a linear change. Okay, so because price and interest rate are inversely proportional, so whenever you see the debt, whenever you see the change of whenever you see the change, we believe that the changes we believe that the changes is inversely inversely related. So we believe this change between the price and the YTM, that the change between the price and the YTM is inversely related. And this is basically that the rate of change of price with the rate of change in the yield till maturity of the debt instrument is basically measured by duration. Okay, so the rate of change of price, change rate of change of price, rate of change of price of the debt instrument, rate of change of the price of the debt instrument with respect to the with respect to the change in interest rate, with respect to the change in interest rate with respect to the change in interest rate is measured by duration. Is basically measured by duration. Is measured by is measured by duration. Is measured by duration. Okay. So we believe that whenever we see the price of the debt instrument, we believe that whenever we see the price of the debt instrument, whenever we see the interest rate, we believe that their relationship is inversely related. Why the relationship is inversely related? That also we have understood. So when we see the formula, when we see the formula of the price of the debt instrument, whenever we see the formula of the price of the debt instrument, and here we can easily understand the coupon is constant, face value is constant, so that means the price is inversely proportional to YTM. So because the price is inversely proportional to YTM, so if you want to measure the rate of change of price with respect to the rate of change in interest rate where they are inversely related, that is basically we measured by duration. So when we talk about duration, so mathematically how I can derive duration, mathematically what is the formula of finding duration. So mathematically this is the formula for the finding duration. This is the formula for finding duration. So this is the formula. So with this formula we can find duration. So once we talk about duration, durations are basically two type. Either they are macular duration or either they are modified duration. So once we find the macular duration, then we find the modified duration of the debt instrument. Okay, so if you see this relation, you know that 1 by P dp by dr is equal to minus of modified duration is equal to minus of modified duration. So I can say dp is equal to minus of modified duration into P into dr. So this is the relation you have to remember, that the price of the bond is inversely related to the change in interest rate. Whenever the interest rate changes, the price of the bond decreases. Whenever the interest rate decreases, the price of the bond increases. So if you want to measure this change, if you want to measure this change, so how much your price is changing by the change in interest rate, so then you can use this formula to find that change. Okay, so like suppose what is dp means the change in the price of debt instrument. Dp means change in the price of debt instrument. Change in the price of the debt instrument. What is dr? Dr basically means change in the interest rate in the market. Change in the interest rate in the market. Change in the interest rate in the market. What is the P? P is the price of the bond. What is MD? MD means the modified duration. If I know the modified duration, if I know the modified duration of the bond, so modified duration, macular duration, basically we calculate them. The unit is year. Whenever we talk about macular duration or modified duration, the unit is basically is in year. So like you can do that part. So let the modified duration is anything. Let the modified duration is 2 year. So let the modified duration is 2 years. So what do you mean by modified duration? Modified duration is 2 year. What do you mean by that? It means that if you hold this debt instrument for the 2 year, you will get back what you paid for this bond. So what you paid for this bond, you paid for this bond the price. So when you will get back that price, because this debt instrument is giving you coupon after every regular interval of time, and then on maturity this debt instrument will give you the face value. So the sum total of the weightage time period which you need to wait, so that you get back the money from the debt instrument, that is basically we called as the that is basically we called as duration. So let the modified duration suppose 2 year, and if suppose then and let the price of the bond is 900 rupees. Let the price of the bond is 900 rupees, and if suppose and if the interest rate and if the interest rate changed by if the interest rate in the market if the interest rate in the market changed by 10 basis points, suppose if the interest rate in the market is changed by 10 basis point, 10 basis point means what? 10 basis point, I hope you understand what is 1 basis point. So whenever you say 1 basis point, 1 basis point basically means 1 by 100 of 1 percentage. That is 1 basis point. Okay, so 10 basis point, if I ask you what is 10 basis point, 10 basis point means 10 by 100 of 1%. That is 10 basis point. Okay, so suppose if the interest rate in the market, if you say if the interest rate in the market is suppose it changed by 10 basis point, suppose if the interest rate in the market suppose it changed by 10 basis point, so how much would be the effect on the price of the bond? So suppose I'm just taking a hypothetical case. So let suppose the modified duration for the bond is 2 years. Let's take this hypothetical case where let the duration of the bond is 2 years and the price of the bond is suppose 900 rupees. So and if the interest rate in the market change by 10 basis point, so 10 basis point, when you say 100 basis point means 1 percentage, 10 basis point means 10 basis point means 0.1 percentage. Okay, so what is the change in price? So then the change in price will be how much? Then the change in the price will be how much? So here the interest rate change by 10 basis point means increase or decrease. So that also you have to tell, because if the interest rate change by 10 basis point, if the interest rate change by 10 basis point, or if it increase by 10 basis point, then the price will decrease. And if interest rate decrease, then the price will increase. So the change in price, I told you the formula dp is equal to minus of modified duration into p into dr. So dp is equal to modified duration suppose is 2, price of bond is suppose 900, and the change in interest rate is 0.1%. 0.1%. So you can write this as 0.1%. So you can find that. So dp would be equal to minus 2 into 900 into this would be 1 by 1000. This would be 1 by 1000. So this so I can do this as 5 za. This is 5 za. So this is minus 4.5. No, this is minus 4.5. Means you, yeah, it means what that mean? That mean that if the interest rate, it means that if the interest rate increased by 10 basis point, then the price of the bond, then the price of the bond is decreased by, then the price of the bond is decreased by, then the price of the bond is decreased by, earlier it was 900 rupees, now it decreased by 4.5. Interest rate increase, so price will decrease. That will become 895.5. This is the what. So we know that part, that the price and the interest rate are inversely proportional. We know that part, that the price and the interest rate are inversely proportional, that we can easily understand with the basic mathematics. Anyone who understands basic maths, he or she can easily understand by looking at this formula, that the price and the interest rate are inversely proportional. So but if the price and interest rate are inversely proportional, then you know that if the interest rate will increase, then the price will decrease. If the interest rate will decrease, and then the price will increase. So if you want to measure the actual change, like in mathematically, if you want to find a value, that if the interest rate change by 1%, then how much the price will change in opposite direction. So if you want to find that mathematically, what the value, so the mathematically, if you want to find that value, then what you need to do, you have to use this formula. You have to use this formula. So when you use this formula, then you will get the answer very easily. Where DP means change in the price of the debt instrument. So DR means the change in the interest rate of the debt instrument. MD means modified duration. Okay. MD basically means modified duration. So you can find this very easily. Okay. Anyone, any doubt, any question you want to ask? So one by one, I have done the derivation of this formula. I've done derivation of this formula step by step. I have explained how this formula came by doing the differentiation of the price of the bond. So we did the differentiation of the price of the bond. So the price of the bond, what we get, we did the differentiation of the price of the bond with respect to the interest rate. So when we did the differentiation, first order differentiation of the price of the bond with respect to the interest rate, then by dividing both the term by numerator and denominator, we divided after differentiation, we divided the equation by the price of the bond. Once we are done with the differentiation, once we are done with the differentiation, we divided the denominator of both LHS and RHS by P. And this all together, we call this as the macular duration. This we all together, we call this as the macular duration. And macular duration divided by 1 plus R%, we call that as a modified duration. Okay, fine. So this you can see this formula, same formula for the duration what I told you. So the same formula, the duration formula what I discussed. Okay. This is the formula of duration, what you can see. Fine. So here what you need to understand, here you need to understand that part that whenever the interest rate in the market changes, the price of the debt instrument changes in the opposite direction. So that relationship we have understood between the price and the interest rate, that they are inversely related. We have understood this. Okay, so once we have understood this relationship, the one thing you need to understand, that the small change in interest rate will bring inverse change in the price of the debt instrument, but very big change in the interest rate will not bring very significant change in the price of the debt instrument. So that is a strange relationship. That strange relationship basically talks about the relation between the interest rate and the price of the debt instrument, that whenever the interest rate in the market get changed by small percentage, then the price of the debt instrument also changed by the small percentage in the opposite direction. But large change in the interest rate does not bring the similar change in the price of the debt instrument. So that shows that the graph between the price and the YTM, if you see the graph between the price and the YTM, that means that the graph between the price and YTM is not 100% linear, because if this would have been 100% linear, then the large change in YTM also bring the large change in the price. But small change in YTM bring the small change in the price of the debt instrument, but large change in the YTM does not bring the similar change in the price of debt instrument. That shows that the graph between the price and the YTM of the debt instrument is not linear. Instead of being linear, it is convex. So instead of this graph being linear, this graph is convex, and this relationship is called as convexity. This relationship is basically we called as convexity. Convexity is very important for exam point of view. This term theory part, so define convexity of the bond, all that is theory part. For exam point of view, it is important for you. So convexity, convexity of bond, very important term. So you can see this. What is convexity? भाई अपना इंटरनेट दो यार मेरे को। हो गया कनेक्टेड हो गया। हेलो, इज एम ऑडिबल, कैन यू हियर मी? हेलो, कैन यू हियर मी? Okay, fine. Sorry, electricity went away, so I am using my mobile internet. So you can see this convexity. This is what I was telling you. So you can see this. You can see the straight line. So the straight line, what you see, that was the duration. So duration basically means straight line. So when you have straight line, if you have straight line curve, then it means that same percentage change in YTM will bring the same percentage change in the price. But in reality, small change in YTM will bring small change in the price, but large change in YTM does not bring the large change in the price of the debt instrument. So that is what convexity is all about. So what is basic? Okay, my voice is breaking, is it? I'm not audible properly. No? 1 minute. And let me use my another internet. Now tell me, can you hear me properly? Is I'm audible? Can you hear me properly? Okay, fine. So I this is you can read by yourself. I think you can see my screen. So convexity is a measure of curvature or the degree of the curve in relation between the bond price and the bond yield. Convexity demonstrates how the duration of the bond changes as the interest rate changes. So other way I can say that convexity is the second order derivative of the change in the duration of the bond with respect to the change in YTM. So the first order differentiation of the change in the price of the bond with respect to the change in interest rate, that was a duration. So if you find out the second order differentiation of the change in the price of the bond with respect to the YTM, or the first order derivative of the change of duration with respect to YTM, what we got as a convexity. So portfolio manager use convexity as a risk management tool to measure and manage the portfolio exposure to the interest rate risk. So you can see this, all this is written. So convexity is a risk management tool used to measure and manage the portfolio exposure to the market risk. Convexity is measure of the curvature in the relation between the bond price and the bond yield. Convexity demonstrates how the duration of the bond changes as the interest rate changes. So if the duration rises and yield fall, the bond is said to be positive convex. While if bond duration increases as the yield increases, and the bond is said to be negative convex. Okay, so you need to understand this. So you need to understand this. So convexity, and if you after the class you can read about convexity, bond duration, convexity, and the risk. So negative convexity, positive convexity. So positive convexity. What is positive convexity? Positive convexity basically means that whenever the yield fall, if the bond duration rise, it is a positive convexity. While if yield increase and the bond duration also increase, then it is called a negative convexity. So you can spend some time. You all have internet. You can spend some time, read about convexity. You can see these graphs. So convexity graphs. So you can see this convexity relation and all, price yield relationship. Fine. So mathematical formula for convexity. Convexity is a second order derivative. This is the mathematical formula of convexity. So once you get the present value of the bond, you multiply that with t plus t square. Once you get the present value of bond, you divide by the t plus t square, multiply with t plus t square. You can see the present value of the bond. You multiply with t plus t square and divide by 1 plus I square. So that is the present value of bond. Present value of bond divide by present value of the bond you got, divide by 1 plus 1.04 to the power 2. Just if I multiply with t plus t square, t plus t square, you can see this. So this is the convexity. You see these values. Do the sum of this and divide by the price of the bond. So basically, what is the formula of convexity? In exam, convexity will not come for numerical. Convexity is difficult to do. So in exam and all, they will not ask you convexity formula. Convexity formula is basically the coupon into one coupon into t plus t square, then divide by 1 plus ytm to the power t into 1 plus ytm square, then this, find the present value of this, then do the sum of this do the sum of this, that is t equal to 1 till n plus the face value. You can find the face value, whatever is your face value, that is n plus n square, divide by 1 plus ytm to the power n into 1 plus ytm square. This divide by the price of bond, divide by the price of the bond. This is convexity. This is the formula of convexity. So convexity is little bit difficult to solve, means mathematically it is little bit complicated. So definitely in exam and all, you are not required to bother much about convexity. It's just a formula. So my purpose was to tell you this formula. So if you understand this formula well and good, okay. So this is convexity formula. What you should be interested with? You should be interested with maculaire duration. So what is maculaire duration? So the formula for the maculaire duration is t into sum of t into coupon, sum of sum of t means time period into coupon, divide by 1 plus ytm to the power t, where t equal to 1 till n. Okay, so you do this, divide, then okay, plus the face value, plus the face value into n into face value, divided by 1 plus ytm to the power n, divide by the price of the bond. This is the formula of maculae duration. So you should be interested in this formula. You should be interested with this formula. Okay, you should not forget this formula. This is very important formula for you people. So for you people, this is very important formula. The formula of maculae duration. This is very important formula for you. The formula for maculae duration. Once you understood the maculae duration, then you should understand the next formula, that is called modified duration. So modified duration is nothing but it is maculae duration. It is nothing but it is maculae duration. Modified duration is nothing but it is maculae duration divided by 1 plus YTM. This is called as modified duration. So modified duration is nothing but it is macular duration divided by 1 plus YTU. That we called as modified duration. So this you should be interested in these two formula. What is the formula of macular duration and what is the formula of modified duration? Okay, everyone. Anyone, any doubt? Anyone, any doubt? Any question you want to ask? So these two formulas are important for us. In exam also we get numericals on this question. You can see this question. You can see this question, this numerical. Exam also numerical based on this only. So you can see the numerical. Arun buys two bond, namely bond A and bond B, with 7 and 8% coupon, having a maturity period of 4 years. The face value is rupees 1000. Bond both the bond yield and will yield 6%. So calculate the duration of the bond. So in exam, this 8 marks question comes. Calculate the duration of bond. When they are asking you calculate, tell the duration of the bond. So like other way, they're simply asking you the macular duration. In other way, they're simply asking you to find the macular duration only. They're simply asking you to find the macular duration only. So it doesn't matter. So we know the relation with both macular and modified. So it's anyway it's coming for 8 marks in exam. So we'll do both. We'll do both macular duration also. We'll do both modified duration also to get the answer. So that would be our objective when we solve the problem. Okay, everyone. So anyone want to ask any question? So the formula what we'll use for the macular duration is T into coupon divided by 1 plus YTM to the power T into T equal to 1 till N. So you can try solving this question by yourself. Plus N into face value divided by 1 plus YTM to the power N divided by the price of the bond. Divide by the price of the bond. We'll use this formula to find the macular duration bond. Okay, this is the formula for the macular duration. Already I have derived this formula. Everything I have spoke about duration. I have spoke about modified duration. All that I have done from my end. Anyone, any doubt, any question you want to ask? Then everyone, so this much from today class. Will continue